On today's episode, we are introducing AeroBarrier, the game changer for the UK air sealing market.
From prep and setup, which takes the majority of the time, we were actually putting sealant into this building for about 2 hours.
Are you saying we can then guarantee those air tightness tests to be exactly the same?
Exactly the same. If you've got another room that is just pumping sealant through, you're going, there's a big leak somewhere, let's have a look and see what's going on.
Welcome. On today's episode, we are going to be talking about AeroBarrier. Really, this is all about air tightness. So what we're going to do today, we're going to visit a site that we've been working on. We have been carrying out the AeroBarrier process, which really takes a morning or a day, depending on the size of the house and complexity of the house. And at the end of that, you would have an air tightness. We're not aiming to make bad building good, but we're aiming to make good building great. So if you've built your house well, if you carried out the sealing to a reasonable standard, we can come in and we can guarantee an air tightness for you on the day. So overall, with a much more airtight home and with a really good mechanical ventilation heat recovery system, you will save money on your heating bills and you'll also have a much more healthy living environment. So Hugh, as you're in charge of this operation, could you tell us what is air tightness?
Air tightness essentially is the control and measure of leakage to a building envelope. Imagine you've got your home and inside that home there will be thousands and thousands of penetrations through the walls for soil pipes, for water going in.
Electrical cables,
Exactly.
Aerial for TV.
Everything. All those little holes add up.
So turning your airtight layer into like a sieve.
Yeah, essentially. When people say the building should breathe, what they really mean is that the internal area of that building should have fresh air. And the best way to achieve that is through mechanical ventilation and heat recovery. How many people want to be breathing through a brick? Yeah. So, you know, the aim is to have a clean duct coming through the building, not to be taking it through your brick, your plasterboard, your layers of dust and general building material.
So with a mechanical ventilation heat recovery system, the air will be filtered, it will be blown gently into your living spaces, the stale air be drawn out from the bathrooms and kitchen. We are here today to carry out an air tightness test on this house here. This is where AeroBarrier comes in. We've talked about it, but what actually is it and what does it do? How does it work?
AeroBarrier, it's a vapor permeable polymer, a sealing solution. It is a permanently flexible joint mastic. What the process is we will pressurize the building through positive pressure. Whilst that building is under pressure, we will atomize this sealant into particles about as fine as human hair. We'll make a very consistent fog inside of the building of the AeroBarrier sealant. You like mist on a winter's day, essentially. Okay. And as the air leaks out those, like the sieve of the building, it rips and pulls this mist of sealant and it webs across the gaps.
So what it is doing through science then really, it is hunting down and finding the gaps in the envelope of the house.
With traditional air tightness taping and systems, we could build 2 of those houses next to each other, have the same people working the same days, the same hours, the same bits and pieces, and get 2 different air tightness results. And you'll get that every single time.
So we are saying with AeroBarrier, are you telling me we can build 2 houses, and we can then guarantee those air tightness tests to be exactly the same?
Exactly the same.
So here we have our demonstration model. There's some little pinholes here for where a nail might have gone through. AeroBarrier will find the holes and the molecules will go into the hole. As they collide with each other, they will join together and gently, over time, form a seal around each hole. And on the computer, we can watch the air tightness gently drop further and further and further and become tighter and tighter and tighter the longer we leave the system running.
Here's one of the kits and the setup. One main control unit, which is the unit with the blue handles on, and then 6 to 7 sealing stations. This unit here, labelled F, we'll put, you know, F in the lounge, G in the dining room, A in the bedroom 1, B in bedroom 2. It's the software we can relabel and so we know where each one is. And each of these has real-time humidity and temperature sensors and fluid levels. All of these units measure the humidity of the process. When we're spraying the sealant, which is water-based, the humidity in that room increases. So it ticks off when it hits 90% humidity, drops down to 70, ticks back on and does it like that. So if we have one room that's been off for 20 minutes, you go, that room's really, really tight. It's not going to be sealing anymore in there, and the humidity will stay constant. But if you've got another room that is just pumping sealant through, you're going, there's a big leak somewhere, let's have a look and see what's going on. The aim with this is we're not trying to point sealant at where we think the leaks are. The aim is to create a consistent fog and allow the sealant to find the leaks itself. It doesn't stick to any vertical surfaces at all. Even at finish level, you could basically have a picture on the wall and it won't stick to the glass.
The stage we're at now is we have the AeroBarrier fan set up. We're blowing at 50 pascals into the house. The sprayers are all gently blowing the spray into each room. So the AeroBarrier vapor is within the house. We've got the brain there and the computer, so we can watch on the computer there as the air tightness increases, the air leakage will go down. So who will gain the advantages from AeroBarrier? Well, really, I see it as being three principal parties. There are self-builders, general construction, then there are developers, and then there are architects. Number one, advantages for the self-builder. Well, this is really where I see AeroBarrier coming right into its own. Most self-builders are going to want to be building a high-quality home, as high as they possibly can. It's your family home, it's your dream home, it's a home you're going to be living in for a good while. Passive house air tightness used to really be in the preserve of the person who's going to build a passive house, which traditionally would be very rectangular, very box-like, possibly a mono-pitch roof. And if you wanted to build a complex home like the one behind me here, really trying to achieve a passive house level of air tightness was almost unattainable, and certainly it was incredibly time consuming and hence incredibly expensive. The great thing with AeroBarrier is you can gain your passive house level of air tightness without the time and without the cost. That will reduce your heating bill considerably, and that will give you a return on investment of around about 3 to 5 years, and then you're going to make that saving going forward year after year after year. AeroBarrier advantages number two is for the developers. We can come in and give you an air test, and the air test is guaranteed. If you have 6 different styles of house and you're building 150 houses, you can have exactly the same air test for every house across the whole site. With modern insulation and glazing and achieving air permeability of 5, which is building regulations, on the same day for no extra cost, we can achieve an air permeability of 3. So that will help in the saleability of the property for a developer. AeroBarrier advantages number 3, architects and designers. So for architects and designers, historically, you have been able to specify everything on the construction. So what type of insulation, how the insulation is applied, that you're going to eliminate all cold bridging. But when it came to air tightness, you could specify the desired air tightness, but nobody really knew. It is the lucky rabbit's foot on the day of the air tightness test and fingers crossed hoping to achieve the air tightness. Whereas now that lucky rabbit's foot can be pushed to one side and AeroBarrier can allow the architect to confidently specify an air tightness, and that can be achieved. I think here, we've been trying to find the little bit, we can just about see in a gap here where the air would be creeping out, and it's sealed that point there. So AeroBarrier, what have we achieved? On this house, we started off air changes of 2.2 per hour at 50 pascals. So that's pretty good, but we are still losing air after the test. Hugh, what did we achieve?
So we hit a final air changes per hour number of 0.1, which is probably some of the top 10 I've ever seen.
That's fantastic. So we managed to achieve that in a day?
Yeah, in a day. From prep and setup, which takes the majority of the time, we were actually putting sealant into this building for around 2 hours.
So we have achieved a final air exchanges of 0.1 at 50 pascals per hour. That is absolutely fantastic. If we'd achieved 5 air exchanges per hour,
that would mean that the air inside that building is changing once every 12.5 minutes, which sounds huge, doesn't it?
Is the window left open?
Well, essentially it's the same as having multiple windows open. This house, when we'd finished, it was once every 10 hours.
Once every 10 hours?
10 hours.
So return on investment of around about 3
to 5 years.
3 to 5 years. This really is the future of air tightness in construction.
Absolutely.
That's great. I hope you've enjoyed today's episode, and if so, like and subscribe to AeroBarrier UK and leave us some comments. Let us know what we can do for you and how we can inform you at AeroBarrier in the future.